Once again, you all are welcome in my channel. Today we are going to discuss the propositional logic in artificial intelligence and how it is different from the predicate logic. Actually, I found many videos on the net, but no one explain this in a quick and easy way. So I'll try my best to make it quick and easy. First of all, you have to understand what is the propositional logic. So propositional logic has the terms defined, is the simplest form of logic where all the statements are made by propositions. A proposition is a declarative statement which is either true or false. So by the mean of this, it is a technique of knowledge representation in which we represent each and every sentence in a logical and a mathematical form. Mind it, every sentence in artificial intelligence or a knowledge representation we used in case of propositional logic, we just involve two things. One is the logic, another is the mathematical form. These are some examples of the proposition, like it is Sunday, the sun rises from the west, which is what we call false proposition because the proposition may be true or false. So 3 plus 3 is 7, which is again a false proposition. 5 is a prime number, which is a true proposition, or what we in simple word is called proposition. This is not a logical proposition logic, but this is these are the examples of the proposition, not the propositional logic. So we'll move forward. These are the some basic facts about the propositional logic. We will cover this logic in the coming section. Propositional logic is also called a Boolean logic as it works on 0 and 1. This is very important statement. Another one is the propositional logic. We use symbolic variables to represent the logic. We represent each and every statement with the some symbols, maybe A, B, C, D, P, Q, R, anyone. So proposition can be either true or false, that I already told you. Propositional logic consists of object, relation, functions and logical connectives. These connectives are called logical operators. We will cover this soon. Actually, logical operators are like and or negate. So we will cover it later on. So move forward. Proposition and connectives are the basic elements of the proposition logic. Connectives can be said as a logical operator with two sentences. This is very important. The proposition formula which always true is what we call tautology, and the proposition formula which always false is what we call contradiction. So we'll move forward. These are the very simple properties. So move forward to the syntax. Yes, syntax of proposition logic. This is very important. The syntax of propositional logic defines the allowable sentences for the knowledge representation. These are of two types. Number one is atomic proposition and another one is compound proposition. Basically, atomic proposition means the proposition which are simple and having an answer in the form of true and false. That is what we call atomic. Like 2 plus 2 is 4. This is an atomic and it is true. The sun is cold. This is an atomic but it is false. Similarly, the compound propositions, as the name suggested, it is the combination of two sentences, like it is raining and the street is wet. This is what we call compound proposition. So we'll move forward. This is very easy. Logical connectives. This is very important. You have to understand this. Negation means if I am saying he is a boy, its negate is he is a girl. He is not a boy. So this is what we call negation, and it is represented by this symbol, or sometimes it is represented by this, like a wave, sometimes with this and sometimes with this. So you can use any one of this symbol. Conjunction, a sentence which has a connective like this is called conjunction. Conjunction is in other terms what we call and I give you a hint. In this is a downwards n, so the downward symbol is what we call conjunctive. Conjunctive means and means multiplier. You have to just remember this. I'll cover it later on. Like a sentence, if we are talking about in a sentence, Rohan is an intelligent, Rohan is hardworking. So Rohan is intelligent and he is a hardworking. So we can write it like this. Disjunction is basically a or operation, and it is upward V. It is just like a V, and it means it is an or operation, or means addition. How why I'm saying addition, I'll tell you. I'll clear it this thing with the help of truth table. Now let us suppose we have an example. Ritika is a doctor or engineer. So since or is coming there, so or is represented by V. Simply in the same way, there is one more term, that is what we call implication. Implication is just like a unidirectional function. It means it is implications are also if then else. If then means if it is raining, then the street is wet. So streets are wet only if there is raining. So this is represented by this P when Q. Similarly, there is a one more operation, that is what we call bidirectional. A sentence such as P bidirectional Q, it means if I am breathing, then I am alive. So if any one of the condition is false, then it is false, because if you are not breathing, then you die, or if you are not live, then you are not breathing. So these two are we will represent it with the truth table, how I'll explain it. So this is a table basically which summarizes whatsoever I told you. So we'll move forward with the truth tables. This is very important topic. Now truth table. For negation, I already told you, if it is P true, then negate is false, like a NOT gate in a digital electronics. Similarly, conjunction means, see here true stands for 1 and false stands for 0. So true multiply by true, this AND operation is multiply. So when we multiply true with true, it is true. When we multiply true with false, since false is 0, then that's why these are zeros or false. So we'll move forward. In disjunction, it is OR, which is an addition operation. So when you add 1 plus 1, you get 1, that is true. When you add 0 with 1, then also true. Similar in the same way this truth table is constructed. Now talking about the implication, this is very important to understand. In implication, when both are true or both are false, then this is true. Otherwise you have to follow P. Whatsoever Q is, you have to follow here. See, whatsoever the Q's values, you have to follow here. In this way you can learn this. In bidirectional, when both are true or both are false, these are true, otherwise false. You need not to be follow here. This is very important, and this is the difference between biconditional and implication. I am again repeating. In implication, when both are true, both are false, then it is true, otherwise you have to follow Q. And in bidirectional, you need not to be follow anything. When both are true or both are false, then true, otherwise it is false. Mind it, for constructing the 3 variables proposition, you have to make it 4t 4f, then 2t 2f, then 1t 1f. Likewise, this is the way how to construct a truth table. Then negate R, P or Q, whatsoever asking, you can compute it very easily, because for negate R, what you have to do, you have to just negate this R. For whatsoever value of true, you have to make it false. And P or Q, for this you have to taking care of these 2 columns, you have to make it or means addition, you have to add them. And similarly, then you have to implies with negate R, means this result you have to apply with negate R. So for this, what you have to do, wheresoever both true or both false, you have to place true first, otherwise you have to follow negate R. So I hope you understand, and I'll advise you do the practice. So this is very important, the precedence of connectives, which is nowhere explained very clearly. What it means, actually this is the precedence of solving these kind of propositional logic. Let us suppose we have to solve this P or Q. So you have to first of all solve this, then you have to open the bracket or parenthesis, because you have to do the parenthesis first, then you have to negate. Let us suppose I have to solve this. So what I have to do, see, Here with the precedence order, it is clearly mentioned you have to do the negation first, then you have to do the disjunction. So hope you understand. This is the order in which you have to follow the operations. So we'll move forward. What is logical equivalence? Yes, this is very important. Let us suppose you have A, B, and you have to construct a truth table for this and this. When you construct a truth table for this operation and this operation, and if the truth table comes out to be similar, then these two relations are said to be logically equivalent. And we generally represented this with 3 lines like this. So these are the logically equivalents because their truth tables are same. And these are the certain properties, commutative, associative. I am not bothering about this because these are very easy, and I think you should understand and you have an understanding of this. So I am talking about the limitation of the propositional logic, very important, and you need not to be worried. I'll share this document in the description box. Now limitation of the propositional logic is what? Number one is we cannot represent relation like vowel. This is very important. You can't represent this sentence with the propositional logic because all the girls, yes, if it is only girls, then we can write girls are intelligent, but there is no way it is represented all girls or some girls. So this is something what we call limitation of propositional logic. Propositional logic has limited expressive power also because all and every is not covered here, right? And the propositional logic, we can't describe the statement in the terms of their properties and logical relationship. Definitely we can't say what is the relationship. We just say P is depending upon Q or Q is depending upon P, but we can't say what is their relationship. So with these limitations, we have to cover these limitations. So for this we made another logic, that is what we call first order logic in artificial intelligence. The first order logic is another name it has, that is predicate logic. See, here it is mentioned first order logic is also known as predicate logic. So predicate logic, why it is called predicate logic and how it is helpful? First of all, the very big problem that we face in the propositional logic, that we can't express the relation. Here we can express the relation, and you have because there is no problem of expressing all and some, because objects, there are 3 things that we are covering. One is object, another one is relation, then another one is function. So A, B, people, number, color, these are what we call objects. Relation, it can be a general relation like red, round, or any relation like the sister of, the brother of. This we have to represent. Function, father of, best friend, third, lining, inning. So in basically first order logic, you have 3 things. With these help of these 3 things, you write your logic. How? We'll see it. Now for this you have to understand syntax and semantic. What is this? We'll cover this. See, syntax of first order logic. The syntax of FOL determines which collection of the symbols is a logical expression in first order logic. The basic semantic, we write the statement like this in FOL. So to understand FOL, you have to first of all understand these terms. One is constant, that is a constant number or name, something. Variable that do not have a fixed value. Predicates like a father, brother. Functions like a square root, left, right, these are the function. Then connectives like the same that we read earlier. Equality, double equal, and quantifier. This is for all, this is for every. So here also there are atomic sentences. Atomic sentences are what we call the basic sentences, like Ravi and Ajay are brothers. So how to write it in the predicate value? You have to write first of all the relation, how these two are related with each other. These are the brothers, so we have to write brother. Then within a bracket you have to write who are the brothers. So this how you can mention this sentence with the predicate logic. Like simply Chinky is a cat, then Chinky you have to write it. Means whatsoever the noun, whatsoever the value of the noun, the name, you have to write it within the bracket, and whatsoever the relation, that you have to write outside. Similarly for the complex sentence, how we can write it? Like X is an integer, you have to understand this. X is an integer, this is what we call subject, this is what we call predicate. So how you have to write it? See, there are two kind of quantifiers in the first order logic or predicate logic. This is very important and very important for the exam point of view. One is what we call universal quantifier and another is what we call existential quantifier. This is for all, this is for some. So we will cover this first. Universal quantifier. Universal quantifier is a symbol of a logical representation which represents within the range of true everything, means it is for every. And one very important thing is whensoever you are represent any sentence with a universal quantifier, you have to use this sign. This is very important. Like for all x, so it means you have to, for each x or for every x, will cover this. Like all man drink coffee. So how you can represent this? You see this diagram. X1 drinks coffee, X2, these are the mans which are drinking coffee. So there are so many mans who can drink coffee. So first of all you have to create the universe of discourse, that is so many mans are there and all drink coffee. So how it is represented? It is represented like this. All man, this is for all, this is a symbol V, then cross, all man drinks coffee. So it will be read as there are all x, where x is a man who drinks coffee. So x we targeted with the mans and they all are drink coffee. Minded this symbol. For universal quantifier you have to apply this symbol. Now come to the existential quantifier. Now existential quantifier we represent for some, and very important thing is for essential quantifier you have to use this symbol. If you use this, then it is a universal quantifier. If you use this symbol, then it is a essential quantifier. So here again we'll take an example. Let us suppose some boys are intelligent. Now we are talking about some. Earlier we are talking about all. So some means there are some boys, those who are intelligent. For this also you have to create a universe of discourser and then you have to write it like this. This is a symbol for some, like it is a opposite E, and boys, some boys, this is very important. This is a sign of essential quantifier, are intelligent. So it will be read as there are some x, where x is a boy who is intelligent. So these kind of qualities properties is not available in the propositional logic. That is what we call their limitation, but these limitations are overcome in the predicate logic. So hope you understand. And one last thing left, points to remember. The main connective for the universal quantifier is implication. This is very important, and mind it several times. This is the mistake only that the student has done. The main connective for the essential quantifier is this connective, or if you are not doing this, then you will get a 0 marks. So properties you have to remember. There are some properties. You can write it like this: for all x, for all y, it is similar to for y or x, like this. These are the commutative or like properties. This is very important and easy. So let us take some examples of FOI. All birds are fly. All birds fly. So this we can write it like this: fly, bird, simple. This is the propositional logic kind of thing, and by this we are representing with the propositional logic. And by this, because all birds we are saying, so all birds, for all birds, this sign very important, because for all you have to use this implies sign, and fly. Similarly, every man respects his parent. So for this every, you have to use this quantifier, that is essential quantifier, and it is, you have to write it like this. Similarly, some boys plays cricket. For some, you have to use this. Now if we are talking about the complex sentence, in complex sentence not all students like mathematics and science. So first of all you have to create not all hope you understand. Not all means this quantifier, universal quantifier. Similarly, only one. So for some students, if we are talking, we have to use essential quantifier. So hope you understand how to represent these quantifiers with how to represent the sentences with the help of these quantifiers. So I'll request you to do the more practice on the predicate or FOL logic, and mind it one thing, FOL is called predicate. So sometimes it is asked in the exam, write the predicate or FOL logic, so you need not to be confused. So hope you like this video, and I'll advise you to do as much as practice you can do on predicate logic, because one question definitely will be asked from this topic in the exam. So hope you understand and like this video. I will come with more innovative video in subsequent sections. Till then, thank you, stay tuned, bye bye.